Hi everyone, it's Mr. Baker here. Today we're looking at circular motion and angular measurement. Okay, so this is a new topic all on circular motion. And so let's have a look at what it's all about. So why is circular motion so important? Well, things change direction in the universe. Planets orbit stars, and so do satellites that are used to communicate around the world. Cars travel around corners. So in other words, it's really important for physicists to understand circular motion to be able to describe everyday motion and to be able to predict future motion. It builds on your understanding of forces and acceleration and also on your knowledge of waves. The same terminology is also used in our study of oscillations, which you'll do in future lessons. So a good understanding of this topic will help your understanding of future topics too. So it links in lots of stuff you've already done, and it sort of bridges to other things that you'll do in the future. So it's a really important one. No pressure there. So today specifically we're going to be looking at angular measurement, and we're going to be looking at what units do we use to describe angles. And so you'll know that we use degrees most of the time to measure angles, but you might have also heard or might have even used radians as well, and that's what we're going to look at specifically today. So radians are units for measuring angles, just like degrees are, and they can be used instead of degrees or sometimes converted between the two. And this is what a radian is. One radian is the size of the angle formed at the centre of a circle by two radii which join the ends of an arc equal in length to the radius. What? So, that's the radius of a circle. That's the origin O in the centre. Radius R. So if I had an arc, that length, the length of that radius there, just arcing around, so that line there is the same distance, same length as this line here. So the arc is the length R. Okay, so then this angle here that's subtended by that, which is just called X, could have called it anything, that angle there is a radian. Okay, 1 radian. So we've got the radius of a circle, the length of the arc, which is equal to the radius. Just put that back again, and we get our angle, which is 1 radian. And we can write that as 1 radian, or we can write it as 1 rad, or you can even use this symbol here, 1, and then sort of to the power of c kind of thing. So it's a c there. So you could use that. A lot of the time, most of the time, we just use rad. So that's 1 radian. If the arc is 2r, then the angle is 2 radians. So if that's the radius, and if my arc is 2 times that, then we have an angle of 2 radians. And guess what? If it is 3 radians, the arc, then the angle subtended is 3 radians. If the arc is 3.14 r, then the angle is 3.14 radians. And 3.14, you will know, is pretty much pi, isn't it? Okay, so it's quite an important number when we're talking about circles and things, and angles. So if the arc is pi r, so that's the radius r, the angle is pi radians. So if the arc is pi r, the angle is pi radians, which kind of makes sense because we were just talking about if the arc is 3 radii, then the angle is 3 radians. If it's 2, then it's 2. So if it's going to be pi, then the angle is going to be pi radians. Okay, so the angle, if we've got an arc of pi times the radius, pi r, equals pi radians. So we've said this, if the arc is pi radians, sorry, if the arc is pi r, then the angle is pi radians. And we've drawn this diagram. But pi r is half the circumference of the circle, so the angle is 180 degrees. Okay, so we know that this angle here is 180 degrees, and we've just said that this angle here is also pi radians. So this is really important because then we can start to convert between degrees and radians. So we can say that pi radians equals 180 degrees. And so we've got this really nice way now of converting between radians and degrees. We know that pi radians equals 180 degrees. So now I can use that to convert between the two. So we said this, pi radians equals 180 degrees. So then that means that 1 radian is going to be 180 degrees divided by pi. Okay, so we've just rearranged this, pi radians. So 1 radian is going to be 180 divided by pi, which is about 57.3 degrees. So we've said that that is our definition. This angle here is our definition of 1 radian. We now know that 1 radian equals 57.3 degrees because we've just found that out from our little conversion that we can do, knowing that pi radians equals 180 degrees. And as I've used this word a little bit throughout this little clip, we sometimes say that the angle at the centre is subtended by the arc. So you might hear that word, we might see that word being used. So this angle here, we just sometimes say that that's subtended by the arc. So this is what we know. 1 radian is the size of the angle subtended by the arc of a circle equal to the radius. We know that pi radians is 180 degrees. We know that 1 radian is 57.3 degrees. So let's have a look. So what I suggest you do is to pause the video and see if you can do these, just as a little bit of practice. Okay, so just pause it and I'll show you the answers in a second. Okay, have you done them? Okay, let's have a look then. So pi over 2, we write down the equivalent number of degrees. So this is in radians, what degrees have we got? So pi over 2 is 90 degrees, pi over 3 is 60 degrees, 2 pi is 360 degrees, and pi over 6 is 30 degrees. So make sure that you work through that. We know that because pi radians equals 180 degrees, and so we can convert between the two. Right, have a look at number 2 now then. Write down as a fraction of pi the number of radians equal to the following. So 60 degrees is pi over 3, 45 degrees is pi over 4, 120 degrees is 2 pi over 3, and 30 degrees is pi over 6. And as it suggests there, it's really useful to memorize some of these conversions just so that you can just quickly do it. When you're doing some questions on this, maybe in an exam or something like that, you just know that that's the number of degrees, or you know that that's the number of radians. You don't have to work it out or anything like that. So this is what we've looked at then. So we've looked at angular measurement, and we've looked at what units do we use to describe angles. We've talked a lot about radians and how we can convert between radians and degrees. That's it for now. And